Here, we're going to write each compound inequality in interval notation and graph it on a number line. Graphing on the number line will help facilitate the process of writing the compound inequality in interval notation. So in this first example, -5 is less than or equal to x, and x is less than 4. Okay, so even though that's written as a three-part inequality, it's really an and statement, right? -5 less than or equal to x, and x less than 4. Okay, but on the number line, it's really easy to see when it's written in a three-part inequality that x is between -5 and 4, right? And at -5, we have a closed bracket there, right? Because we have -5 less than or equal to, right? And then up here at x equal 4, we have an open bracket, right? Because it's x strictly less than 4, and everything in the middle, right? Okay, so if we write that in interval notation, we're going to have, with a closed bracket, -5 to 4, right? The interval from -5 to 4. And we have a closed bracket at -5, and because we're including -5, and we have an open bracket at 4 because we're not including 4. Okay, so now in this next example, we have -2 less than or equal to x, and x is less than 3. Okay, so that's written out as an and statement. The way this is written out, you notice that all of those inequalities are pointing the same direction, right? So we have -2 less than or equal to x, and x is less than 3. So if we wanted to, we could write this as a three-part inequality, as -2 less than or equal to x less than 3. Okay, and again we have less than or equal to sign at -2, so we'll have from -2 with a closed bracket up to 3 with an open bracket, and everything in between. Right, so closed bracket at -2 and an open bracket at 3 for our interval notation, right? -2 to 3. Okay, now one more and statement. X is greater than -1, and x is greater than or equal to 3. When x is greater than a number and also less than a number, you can write it as a three-part inequality. In this case, with x greater than a number and x greater than a number, not so much the case. Okay, so let's just graph both of these. And because I don't exactly know what interval I'm going to be looking at in the end, I just want to graph them both separately. So I'm just going to graph them above the number line here for a second. So if I've got x greater than -1. Now, by the way, a little trick if you're wondering, like when you're graphing inequalities on a number line in general, if the x is on the left-hand side, like x greater than -1, the inequality will point the way you need to shade the number line, right? So because it's greater than -1, it's the arrow's pointing to the right, so I'm going to shade everything to the right on the number line. Just a little trick. Okay, and then also x greater than or equal to 3, right? Again, it's pointing toward the right, so I'm going to shade it this way. Okay, so I wanted to graph both of those kind of above the number line to just take a look at those two intervals, because what is it that they have in common? Because this is an and statement, so we want their intersection, right? So the elements that are common to both x greater than -1 and x greater than or equal to 3. What is that? It's just the stuff from 3 to positive infinity, right? And I'm including 3 because 3 is included in both of those intervals, right? So in interval notation, I would have -3 to positive infinity. And we always write, when we're writing infinity as one of the endpoints, we always write that with an open bracket because you can never quite get there, right? Okay, so let's look at this or statement, all right? X less than -4 or x greater than or equal to 0. So because it's an or statement, when we state the interval notation, we have to state everything we see in both intervals. All right, so let's take a look. X less than -4, the arrow's pointing to the left, right? So I'm going to have -4 out here to the left on the number line with an open bracket, right? X strictly less than -4. Or x is greater than or equal to 0. So then I'm going to have a solid bracket at 0. And the arrow there is pointing out to the right. Okay, so I have to include both everything that I just shaded on the number line, right? So in interval notation, I'm going to have negative infinity up to -4 with an open bracket in union with closed bracket 0 to infinity. Okay. All right. Now, another or statement, because they don't all look like that. So this one says x less than 5 or x greater than or equal to 1. Okay, so just for a moment, just like I did a couple of examples ago, I'm going to do this above the number line just to show what's happening. So I have x less than 5, right? So open bracket and everything out to the left there on the number line. And then x greater than or equal to 1. So I have everything out this direction. Okay, now if it were an and statement, we'd find the intersection, right? But with an or statement, we have to include everything we see there, including the intersection. Okay, so if I were to graph the solution of this on the number line, I just shade the whole number line, right? The whole number line is included with those two intervals, right? So when you state this in interval notation, only state one interval rather than trying to state it as two intervals. You could write both of those intervals, x less than 5 and x greater than or equal to 1 in interval notation. Why write two intervals when one will do, right? If we're shading the whole number line, then in interval notation, this would be negative infinity to infinity, right? So in this last example, -6 greater than x or x less than -1, that little trick I've been talking about with shading the number line the way the arrow points, it only works if x is over on the left. So since we have -6 greater than x, it's the same thing as saying x less than -6 or x less than -1, right? Okay, so let's graph this. X less than -6, so we're going to start here at -6 and head out to the left. And with x less than -1, at -1, we're also going to head out to the negative side, right? To the left, so x less than -1. Okay, so what's shaded there? Well, the stuff from -1 to negative infinity, right? So remember the or statement means we're shading everything including the intersection there. So in interval notation, we'd have negative infinity to -1. With an open bracket, right? We're not including negative infinity, nor are we including -1. Okay, good. So hopefully that you are getting a sense of this with the and the or statement, what you're looking for, and make sure you graph both of the intervals and then ask yourself what do I have? Do I have an and statement where I have to find the intersection, or do I have an or statement where I have to include everything I see?